Hello dear students. Let us see what is the relation between array and pointer. So as you see, the topic is about array and pointers. Now to understand the relation between array and pointers, let's see a very small code over here where in the first line after main we have declared an array and we have initialized the array. The array has been initialized to 5 integers as you see 10 to 50 and the picture of the array has been shown on the right side. We know that location numbering in array will start with 0 and go up to 4. Now what we have to understand is that the name of the array which is A indeed is actually a pointer. I repeat, the name of the array that is A is actually a pointer, and this pointer stores address. This pointer will actually store the address of begin address of the array. Let's assume that this array starts at location 100 in the memory, and let's assume that every integer consumes 2 bytes. I repeat, on some systems integer might consume 4 bytes, on some systems they may consume 8 bytes. I'm assuming that on my system this integer will consume 2 bytes. So the next integer, that is 20, would be immediately stored at 102 location, correct? Because first integer goes at 100, 101. So second will obviously get stored at 102. So what about third element? Third element would be stored at 104. That is element number 2. That is 30 will be stored at 104, 40 at 106, and 50 at 108. These are the locations where each element of the array takes 2 bytes. Okay. Now what I was telling is that the name of this array A itself is the address of the array. So in your program, I am writing in short here. If you write print A, let's say, simply the name of the array, print A. I am not writing printf and grammatical part of the C language. I am just writing in short. If you write print A, then this will print 100. A, the name of the array itself, represents the begin address. We call it as base address of the array. Pictorially, we can assume that A points to 100. That is, A stores the address of the array. What is the address of the array? A is 100 because the base address of the array is 100. So, if you are thinking about what is relation of array and pointer, next time if you are asked what is an array, you should say array name. That is name of the array. Array name is pointer to the base address. Base address from wherever the array starts in the memory, that address will be represented by the array A. Actually, this diagram of pointer and this A pointing to the array has been drawn by me, but it is not fully correct. I mean, fully correct by meaning, what I mean is that you don't often show this A as array pointing to this particular base address. But what we assume is that A itself is the address of the array. A, if I write A, itself is the address of the array. Now, if A is the address of the array, then we are driven to draw this picture that A stores the address of the array, 100, and A points to it. Okay. So that's why we say A is a pointer. Array name itself is a pointer because it stores base address of the array. So check this printf. If I say address of A0, just check. I want to print address of this element which I am marking over here. What is this exactly? This is A0, isn't it? 0th element. And if I want address of this, if I want address of A0, which is 100, address of A0 is 100, I can simply write A. If I write A, I know that I am going to get 100 as the output, which is the address, indeed address of A0. Now, another way of writing this was AND A0. You know that when I write AND A0, I am asking for address of A0. So both and A0, A, both these conventions, either you write and A0 or you write simply A, both these conventions will give address of A0. Next starts very fun part. You see, the next printf which I am underlining, I want address of A1. Address of A1 means this element which I am marking here. One way to get the address, I mean to know the address of A1 is simply write and A1. So I am asking what is the address of first element of the array, but the other way is simply write A plus 1. Just check this. Simply write A plus 1. Now here starts the confusing fact. When you write A plus 1, any beginner would feel, okay, I have to add 1 to A. And what is A? Check this. What does A represent? A represents 100, address of the array. Then one might just substitute A as 100 here, add 1 to it and say that the result of this is 101. Just check. Result of this 100 plus 1, anybody would say is 101. No. When you add 1 in this situation to an integer pointer, just check where is A pointing. A is pointing after all to an integer array. It is pointing to the first integer of the array, which is 10. Which type of pointer is A? A is after all integer pointer. When you increase integer pointer by 1, it gets incremented by 2. Just check this. Suppose I increment a int pointer by 1, then it gets increased by 2, assuming that every integer consumes 2 bytes. So please try to understand this A plus 1, this A plus 1 is going to give you 102. A was 100 and you added 1 to it. But A is an int pointer. Please try to understand. You are adding 1 to the integer pointer. When you add 1 to the pointer, it jumps. It increases by 2 bytes. Because every int consumes 2 bytes. Okay. So what will be the output printed by this statement? The second statement, printf, the value of A plus 1. The value of A plus 1 printed over here will be 102, and 102 is exactly address of A1. That's right, A1. I hope you are understanding. So how will you print address of A3? Just check this, although not given in the code. A3. One way is writing and A3. You will immediately get the address. Other way is just add 3 to A. So what is A? A is 100. You are adding 3 to it. That means you are jumping over 3 integers. That means you are jumping by 2 bytes, then again 2 bytes, then again 2 bytes. So obviously when you add 3 to 100, this would be 106. And that exactly is address of A3. Okay. So in general, how do you get address of AI? Think of some element, ith element. One way is you write and AI, and the other way is just write A plus I. A plus I. A plus I will give address of AI. So this convention and this convention both are same. I hope you are getting it. So now the most interesting point with respect to compiler, C compiler, I am telling you. What's very interesting over here to understand, is that we programmers often write scanf like this. Scanf for arrays, I am saying scanf %d and AI. So we are scanning ith element of the array. So whatever value we input will go in the ith element. Now we write like this, but actually C compiler will modify this to A plus I. I mean, when we are reading our program in Notepad, we will obviously see and AI because this is what we have written. But this gets modified to A plus I. Why? Because any ith element address, if you want to reach ith element, then go to base address first. Where does the array start? Go there and add I to that base address. Now when you add I to the base address, then we are going to ith location because we get the address of ith location. Interesting, isn't it? So any programmer would be under an impression that address of AI I have written like this, so this is my code, but this gets transformed to A plus I. Okay, once we have seen how do you get the address of any element using the array as a pointer, now the next thing is, how do you get the value stored in the array? Just check next few lines. Here is value of A0. Just check value of A0 is asterisk AI. Actually, if I want to print value of A0, I can simply write A0. I will not write AND now because I want the value. So A0, as you see, is 10. Whereas AND A0 is 100. So if I want value, I would write in my program A0. But the other way of writing this, another method of writing this is, you write asterisk A. Now just check, what is A? A is a pointer to 100. Come on, A is storing 100. So if this is the address, what do you mean by asterisk followed by pointer? Asterisk followed by pointer gives you the value to which the pointer points. Isn't it so? So if A points at 100, then asterisk A will give 10, value to which A points. Or you could have written this A0 as asterisk A plus 0. This. So first add 0 to A, but adding 0 to A will result in A itself, and then asterisk for the value to which that pointer is pointing. Okay, just check. How will you get A1? This value you want, 20. Maybe you want to print this value. So you'll give printf, %d, comma, A1. Of course, you won't write AND because you want the value. This is one way. The other way is, instead of writing A1, you can even write A plus 1. Tell me what is A plus 1. Just check. What is A plus 1? A is 100. Check the picture. A is 100. You are adding 1 to it, but you are adding 1 to the integer pointer. So what is this bracket? This bracket is 102. You are adding 1 to the integer pointer. And what is 102? 102 is the address of 20. Now, if you write asterisk operator before that, you will get value stored at that address, isn't it? Think over it. What that means is, we programmers write array notations like this. I want first element of the array. I want to print second element of the array. But these notations get transformed by our compiler in this fashion. So what is this asterisk A plus 2? It is value of A2. Just observe. Now think, I am not drawing an array anymore, okay? Think of that if I write printf, %d, AI, suppose. That means my intention is I want to print ith element of the array. Whatever is stored at ith element, I want to print it. The other way is that I could have written printf, %d, first add I to A, and then put asterisk before that. Now what is this bracket going to give you? This bracket will give you address of ith element of the array A. So you know what you are doing? You are reaching that element first because you got the address now, and then you are putting an asterisk to say that I want value stored at that address. Okay, so how do you get address of particular element and how do you get value? If you summarize it, given array A, to find or to get address of ith element, that is, you want to get AND AI. What is the address of ith element? You can write A plus I. Simply this is going to give you the address of the ith element. But then to find value of AI, what is that value stored? If you want to print that value, then you first find out the address, and then use asterisk operator to get the value stored at that address. Okay. Now, many interesting things about array and pointers are to be seen here. Just check what's very interesting. I am telling you a definition here now. You know that the name of the array itself is the address of the array. I'll write that observation first. Name of the array is address or begin address of the array. First thing. The second very important thing is that name of the array is constant pointer. This is so important. It's a constant pointer. What it means is that suppose we have some array. I'm not drawing the elements and like 10, 20, 30 and the addresses. But you know that A is a pointer to the begin address. Now, you cannot write in your program A equal to A plus 1. Nowhere we have written anything like this in this program. What you are forcing, by writing this, that you are saying A should change. A should become A plus 1. That means A should not point where it is pointing, but A should point to 2 bytes ahead, because I am saying A plus 1. A plus 1 means 2 bytes ahead. So we are saying A, which was pointing to base address, should not point anymore to base address, and it should point 2 bytes away from its location. This is not allowed. If you try to permanently change the value of A, compiler will give an error that you are attempting to change the value of constant pointer, which is not allowed. So if you declare an array, check this point. If you declare an array, the name of the array is the address of the array. Agreed. So it is pointer to the array. But that pointer cannot change its location. That pointer will always keep pointing to the base address of the array. That's why it is known as constant pointer. Think over it. Why this rule must have been imposed? Come on, you have declared the array in your program, correct? So compiler has reserved some memory for your array from some location, maybe 100, correct? And it goes on. You are using the memory from location 100. And it has been told to A that A, you are 100, so you know where the array starts. And suppose we were allowed to write this A is A plus 1 or 2 or 3 and move this pointer to some other location, then actually we are dislocating the array from its place. What about the memory assigned by the compiler in this region? Once you move the array over here, the pointer over here permanently, you are actually disrespecting the memory which was allocated by the compiler for these many locations. So although you can say A plus 1, A plus 2, that means temporarily you are adding 1 to A, temporarily you are adding 2 to A, but you are not changing the value of A in any of these conventions. You are not saying A should become A plus 2 or A should become A plus 3, which is not allowed. So remember these facts about pointers. Some more things we will learn as we proceed in next videos. Thank you very much.